In today's digital age, images and videos are an integral part of our daily lives, and the ability to analyze and understand visual data has become a crucial aspect of many industries, from healthcare and security to entertainment and marketing. Convolutional neural networks are a type of deep learning algorithm that have revolutionized the field of computer vision, enabling computers to recognize and classify images with unprecedented accuracy. In this video, we will delve into the world of CNN, exploring their architecture, applications, and implementation, and discover how these powerful models are transforming the way we interact with visual data. So let's get started with understanding convolutional neural network in everyday language first, and then we will go through the convolutional neural network in technical languages. So imagine you are an owner of a bakery and you want to build a machine that can recognize different types of pastries like cakes, cookies, and bread. You want this machine to look at a picture of a pastry and say, ah, that's a cake or that's a cookie. A CNN is like a super smart computerized version of that machine. It is a type of artificial intelligence designed to recognize patterns in images like the shapes and the features of pastries. So how does CNN actually work? Let's go back to the bakery example. Imagine you have a big box of pastries and you want to train the machine to recognize them. So first of all, the machine will look at the picture of pastry like a cake. Then machine breaks down the picture into smaller parts like individual pixels, which are tiny dots that make up the image. It is like looking at a cake through a magnifying glass, but instead of just seeing the whole cake, you see individual crumbs and frosting bits. Then machine looks for patterns in these small parts like the shape of cake, the color of frosting, or the texture of the crumbs. It is like machine is saying, oh, I see a round shape and it's brown on the top. That might be a cake. Then in pulling, machine takes these patterns and simplify them, like summarizing a long story into short paragraph. This helps the machine focus on most important features. Then in flattening, machine takes all these simplified patterns and flattens them into long list, like a recipe with all the ingredients and instructions. And finally, in this fully connected layers, machine uses this list to make a decision like that's a cake or that's a cookie. It is like a machine is saying, based on all these features, I'm pretty sure this is a cake. Now comes the key components of CNN. So filters are like special lenses that help the machine focus on specific patterns in the image. Imagine using a red filter to highlight the color of frosting or a shape filter to highlight the edges of the cake. Activation function are like special sauces that help the machine decide what patterns are important. So imagine using a ReLU sauce that highlights the most important features, ignores the rest. Pulling layers are like summarizers that help the machine simplify the pattern. So imagine using a max pulling layer that keeps only the most important features and discards the rest. Now comes the business applications. So CNN are used in many business applications like image recognition, where it can be used to recognize objects on the roads like pedestrians, cars, and traffic lights. In product classification, online retailers use CNN to classify products into categories like clothing or electronics. In quality control, manufacturers use CNN to inspect products on the production line, like checking for defects in textiles or anomalies in medical images. And finally, security systems use CNN to recognize individuals, like unlocking your phone with your face. Now comes the convolutional neural networks in technical words. So we know convolutional neural network is a type of deep learning algorithm that is particularly effective for image classification tasks. In the context of business, CNN can be applied to various applications such as product classification, quality control, and facial recognition. Basically, a typical CNN architecture consists of convolutional layers which apply filters to the input image, scanning the image in both horizontal and vertical direction and generating feature maps that represent the presence of specific features at different locations in image. Activation functions introduce non-linearity into the model, enabling the network to learn complex patterns and relations between the data. Common activation functions are ReLU, which is rectified linear unit, sigmoid, and 10H. Pulling layers downsample the feature maps, reducing the spatial dimension and retaining only the most important features. Common pulling techniques include max pulling, average pulling, and sum pulling. Flattening layers transform the output of convolutional and pulling layers into one-dimensional array, preparing the data for fully connected layers. And finally, these fully connected layers are used for classification, where the output of previous layer is used to predict the class label of the input image. Next comes key components of CNN. First are the filters, which are small matrices that are applied to the input image, scanning the image in both horizontal and vertical direction and generating feature maps. The filters are learned during the training process and are used to detect specific features within the image. Kernel size refers to the size of filter, which determines the receptive field of convolutional layer. A large kernel size results in larger receptive field, allowing the network to capture more complex features. Stride refers to number of pixels by which filter is moved over the input image. A larger stride results in smaller output feature map, reducing the spatial dimensions of data. And finally, this padding, it refers to the process of adding zeros to the input image, allowing the filter to scan the entire image and reduce the effect of border pixel. Now, training a convolutional neural network involves data preparation, where data set is split into training, validation and testing set. Training set is used to train the network, validation set is used to evaluate the network during training, and testing set is used to evaluate the final performance of network. Now, in the model definition, CNN architecture is defined including number of convolutional layers, pooling layers and fully connected layers. A loss function is defined which measures the difference between predicted output and actual output. Common loss functions are cross entropy loss and mean squared error. Optimizer is selected, which is used to update the model's parameter during training. Common optimizers are stochastic gradient descent, Adam and RMS prop. And finally, this network is trained on the training set, with the optimizer updating the model parameters to minimize the loss function. Now comes types of CNN, where LeanIt is a simple CNN architecture that consists of two convolutional and two fully connected layers. AlexNet is a deeper CNN architecture that consists of 5 convolutional layers and 3 fully connected layers. And finally, this VGGNet is a CNN architecture that consists of multiple convolutional layers with small filter sizes and large number of filters. Next comes the business applications of CNN, where CNNs are used for image classification tasks such as classifying products into categories, detecting defects in manufacturing, and recognizing facial expressions. Also, CNNs are used for object detection tasks such as detecting pedestrians, cars, and traffic lights in images and videos. CNN can be used for image segmentation tasks such as segmenting medical images, detecting tumors, and identifying objects in images. And finally, the CNNs can be used for facial recognition tasks such as unlocking devices, identifying individuals, and detecting emotions. So in conclusion, the CNNs are a powerful tool for image classification tasks and have numerous business applications including product classification, quality control, and facial recognition. By understanding this architecture, key components and training process, businesses can leverage these models to improve their operation, increase efficiency, and drive innovation. For better understanding, let's understand it using a Python code where we will create a simple CNN using Keras and TensorFlow to classify handwritten digits, which is the MNIST dataset. We'll use dummy data to demonstrate the concept. Also, we will run this code in Google Colab. So let's get started with the code. So this is the Python code. Here we are creating a simple CNN using Keras and TensorFlow to classify handwritten digits. We are using dummy data to demonstrate the concept. So first of all, we are importing libraries where we are importing NumPy for numerical computation, TensorFlow for deep learning, Keras for building the neural network model, train test split from sklearn for splitting the data into training and validation set, accuracy score from sklearn for evaluating the model's performance. Then we are loading the MNIST dataset where dataset is split into two parts, X-train and Y-train. So here we are using 60,000 images and their corresponding labels. X-test and Y-test, here we are using 10,000 images and their corresponding labels. After this, we are having pre-processing the data where this reshapes will reshape the data to have a correct dimension for convolutional neural network. Here the dimensions are -1 is the batch size, which is automatically determined. 28, 28, these are the height and the width of images. 1 is the number of color channels where we are using grayscale image. Then float 32, convert the data to floating point numbers divided by 255 means it normalizes the data to have values between 0 and 1. And then we are splitting the training data into X-train, Y-train, that is where we are using 80% of original training data and 20% of the original training data for validation part here. And then comes the defining the CNN model. So here this Con2D is a convolutional layer with 32 filters, kernel size 3 into 3 and ReLU activation function. Then max pooling layer with the pool size 2 into 2, Will flatten the output of convolutional and pooling layers. Then this dense will is a fully connected layer with 64 units and ReLU activation function. Then this dense 10 is a fully connected layer with 10 units, one for each class, and a softmax activation function. And then we are compiling this model. So where Adam optimizer is used for updating the model's weights, loss function for multi-class classification, and this matrix accuracy evaluates the model's accuracy during training. And then we are training this model. So it will train the model for 5 epochs using the validation data to evaluate the model's performance during training. And then evaluate the model. So it will evaluate the model on the testing data, print the test accuracy, and then using the model for prediction. So it will use the trained model to predict the classes of testing data and print the printed classes for first 10 images. So after running this code in Google Color, we are getting the validation accuracy, validation loss, and final accuracy and losses for each epoch. And then we are getting the test accuracy, that is 0.98, and we are getting the results for each 10 classes where it is showing the predicted classes results. And that's all. You can also run this code in Google Colab and get the same results as shown here. And that's the wrap. Convolutional neural network have revolutionized computer vision, enabling accurate image classification and object detection, and will continue to drive innovation across industries, transforming the way we interact with visual data. Thank you.